With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello student, here our question is charge density of a given surface is S. Okay, here is given the charge density is S, and then electric field strength at the center is how much? Given a quarter sphere. So in order to find the electric field, let us assume a unit means the elementary surface area here, right? On the surface of the sphere, quarter sphere. So if you look at this quarter sphere, that the direction of this elementary area will be normal to this surface, and you can take this in this direction and perpendicular to this surface area. Okay, so due to this elementary area, what will be the electric field at the center? Electric field will be in this direction, obviously, right? Okay, now let us consider okay, this is the vertical one. Okay, this is our vertical angle. Okay, so this elementary surface area is making an angle that is theta with the vertical, so that this electric field also making an angle theta. Okay, for this small elementary area, let us consider that is dE our small electric field, right? Now we can resolve this elementary area into two component, right? In this direction, that is vertically, and horizontally in this direction, right? So this vertically it's making an angle that is theta. Okay, this if you consider this is dA and this is theta, and along the vertical component it will be dA cos theta, and it will be dA, and this component is in dA sin theta, right? Okay, now similarly we can resolve this our electric field into two component. Okay, in this vertical direction, wait, okay, in this the vertical direction, what we got our electric field as dE cos theta, and in a horizontal direction this is dE sin theta, right? This is dE sin theta, and this direction this is dE cos theta. Okay, now we are getting the two component of our electric field, that is dE cos theta along the vertical direction and dE sin theta along the horizontal direction at this point O, at the center of this quarter circle, right? Now what we have to do is, now basically we know that due to this small area our electric field will be how much, that is K, and we are taking this K as a constant, that is 4 pi, this is 1 by 4 pi inert, so directly we are taking K into small charge of this area element, K into dq divided by this distance from center is how much, that is r, radius of this quarter circle or the quarter sphere. Okay, now what will be the charge small element for charge for the small element dq, that is K into dq is sigma, this is the surface charge density, here it is taken S, but let me take sigma for my convenience, right? Sigma into small area element dA, okay, divided by this is r, sorry, this will be the r square term, okay, sorry, this is r square term, right? So we got our electric field means dE as K sigma dA r square. Okay, so along the horizontal direction, what will be our electric field? Along the horizontal direction, what will be our electric field? Let me mention it only EH. Okay, this is taking too long space. This is horizontal. Okay, horizontal electric field, that is we have dE sin theta, right? So in place of d we can take this is K sigma by r square into dA sin theta. Okay, we can take this integration because horizontally we have to integrate this integration, right? Now what will be its vertical component, that is E vertical component equal to integration of all this electric field along the vertical direction, that is dE cos theta, and dE is here K sigma divided by r square, and here this is dA cos theta, right? Now if we look at this diagram, okay, if you consider the small element on the surface of this our quarter sphere, then we can resolve all this area element so that vertically all the area element will be in this direction, upward direction. Okay, if we look at this area element from the top, okay, if we look at this area element from this top, so it will look like a semicircle, right? If we look this area element from the top, it will look like a semicircle like this way. Okay, and that semicircle would have the radius that is r. Okay, now we know that what is this area of the semicircle. Okay, that area element, that is dA cos theta, dA cos theta along the vertical direction is equal to area of this semicircle. It will seems like if we look from the upward, it is okay. If we look at this figure, the bottom surface is a semicircle. Okay, so all the area element that is passing through this vertically, so it will look like a area element covering a semicircle. Okay, area element covering a semicircle, because the bottom surface is a semicircle, right? If we look from the top, that all the areas are emerging, this vertical area are emerging towards the upward direction, and that all the area element is covering a area of this semicircle. Okay, so if we take this integration of dA cos theta, the vertical element of this all this area element, so what we will get, that is area equal to this semicircle. Okay, and we have this area of semicircle is how much, that is pi r square divided by 2. Okay, so from here what we can evaluate, that in case of vertical direction, that is EV equal to this dA cos theta would be how much, that is k sigma divided by r square, and this is pi r square divided by 2. So from here what we get, that is r square will get cancelled out, and we are getting k into sigma pi divided by 2. Now if we look at our horizontal component of this elementary area, that it will seems like it is emerging from in this horizontal direction. Okay, so if we look at this point, okay, this is this look like a semicircle. Okay, so if we look from the side, okay, if we look from the side, it will seems to us that this area element dA sin theta is coming from the area of this semicircle, that is of radius r. Okay, similarly we can assume that the integration of dA cos theta, if we integrate all this area element in horizontal component, that is ds sin theta integration, it will also seems like a semicircle of the radius r. Okay, so from here what you got, that is dA sin theta also have the area same as that of the semicircle, and this is pi r square divided by 2, right? So from here what we have, that is dA sin theta also pi r square divided by 2. From here what we conclude, that the vertical component is also equal to the horizontal component of the electric field at the center, and both of these are equal to k sigma pi divided by 2. Okay, right? And as we have the two component of this electric field, so our resultant component E will be how much, that is root over of L electric field in the vertical direction square plus that of the horizontal component. Okay, so as both of them are same, so we can assume that is E into V or H root over of 2, right? So we have that is E. Now let me put this K equal to 1 by 4 pi epsilon, and we have the sigma as the surface charge density into pi divided by this is 2, and we have this root 2 term in the numerator, right? So now what we got, that is sigma into this pi will get cancelled out, divided by this is 4 into root 2 E naught epsilon. This is our total electric field at the center due to our quarter sphere, right? So if you look at our option, our first option is the right answer.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.